The Nashville music scene is very cool and a big reason why we're based here. In '75, when they opened this facility, it was just to augment production for Kalamazoo. So they initially just created Les Paul. Once the staff started developing their skills, they started adding more models. By the end of the '70s, they were making a wide variety of solid bodies. By '84, they shut down Kalamazoo completely and moved everything into this building. This plant was then Gibson USA. And the charter here at USA is to make solid body electrics and also semi-solid, so the ES line we're making here. The rough mill building itself opened in the early 2000s. Prior to that, all the rough wood machining and processing was done in what is now final assembly. But when you're doing all the rough wood processing, obviously there's a lot of sawdust and contamination like that. That doesn't work well with finishes. When we receive the wood, we check it with a moisture meter, so we get the moisture content. And you typically want to have that wood between 8 and 10%. That's considered equilibrated to where it's going to be stable. If it's too dry, it can split and crack. If it's too moist, it'll dry up later and cause structural problems. Gibson's most known for extensive use of mahogany and maple tops, for instance, on Les Pauls. We start with the raw mahogany lumber and we rip it and cross-cut it into the appropriate sizes. So we'll join the edges to prepare them to be glued, and then we have a rotating glue rack. When we use maple tops for guitars, which the Les Paul is iconic and known for, we have different levels. The iconic models may have a 2, 3, or 4A top. That's the degree of figure, the striation in the grain. So when we get the maple for the top, we'll book match it. The book matching process, the top starts out as an 8/4 blank, which is 2 inches wide. So we split it down the center and open it up like a book, because you'll have that flame matching up at that center and it'll just have that book match symmetry on each half. If it's a solid guitar, we have locator pins so the top will align properly on center to the back. The guitar tops are then sent in a glue application machine that kind of looks like a planer or a thickness sander, but it applies the glue to the top. Then the top is installed on the back of the guitar, and then they're stacked up. So we have hydraulic presses that will hold over 100 guitar bodies in one pressing.
I run what we call a Northwood CNC. I cut out the bodies that have been glued up and rough cut into the shape of a guitar. I work on everything from the standard Les Pauls, studio Les Pauls, flying V's, quite a bit of a variety.
CNC stands for computer numerically controlled. These days, when we design a guitar, instead of drawing it on a drafting board like we did in the old days, we'll do a CAD drawing, and then we'll send that CAD drawing to a programmer. He'll send that program to the machine.
It just made life around Gibson a lot easier when we started getting them in here. They're more consistent than most machines.
In the old days, before CNC, we had pin routers. And you had one operator moving that template and that body over a moving router cutter. Not only is it higher capacity and higher accuracy, but it's higher safety, and that's most important for our employees.
Most of the people here are just really good people. That's one of the best things I think that makes the whole place better. Everybody works together pretty well. Most everybody, is out there to make a good quality guitar and get the job done. And I mean, it's kind of like, just anything we do, you're kind of looking at your next department as basically your customer. So you want to send them whatever they need to make sure the guitar's made the highest quality and everything so they can do their job and then pass it on to the next one.
When you've been here as long as I have, you see them on TV, that's where the pride factor comes in.
Seeing how I make the Gibson guitar, that's the first thing I'm looking for, because if you look for the peg head, it's going to be on there. And then you see the Gibson on there, it's like, wonder how long he's had that one. Might have been one I made, you know. So yeah, it's great. It really is.
We use a variety of woods for various reasons. Tone really is number one. Stability and aesthetic certainly have to be considered, but the great thing with the Les Paul, you know, that was this first time there was a hybrid of a mahogany back with a maple top, and it just created a sound unlike anything else.
Gibson has always been the leading edge of innovation. If you always do the same thing, then you don't make any advances.
The wood that we use for the neck is dimensionally sized so it's closer to the finished form. That way we ensure that we have perfect clarity and grain orientation. Everything has to be quarter sawn. We'll get that wood, we'll have to unstack it and then restack it with the stickers so then we can equilibrate it in the kilns and get that air circulation. On our necks, we'll use a 12-quarter neck blank. However, with the width of our headstock, we glue on what are called ears. That way, it's more sustainable for the wood. It's more environmentally conscious, and you don't have to needlessly waste as much wood to yield a neck. When we machine a neck, it initially starts out on our rotary profiler, which is an old-school chain-driven shaper table, actually. It'll rotate circular around those cutters, and then at each station, an operator will rotate it in the fixture so it does different operations.
We've done that in several areas where we've introduced machinery, and it's not really to take away from the craftsmanship. It's more to make the consistency there so that the craftsmen aren't spending so much of their time trying to get the basic shape and stuff done.
The truss rod is a great story in itself. It's a Gibson invention. Gibson invented the truss rod in 1921. It's basically a bolt that runs the span of the neck. So it's inserted in a slot in the neck, and then there's a maple spline, which is a piece of wood that holds it captive with a slight arc. So when the neck undergoes tension and pulls forward, you tighten that truss rod and it'll want to straighten itself out. Not only does it allow adjustment of the neck, it also allows us to make a neck thinner. When people like Charlie Christian and the early electric pioneers started having these guitars equipped with pickups, they also had thinner necks. And that thinner neck allowed them to play farther up the neck. So without that slim neck and the pickup, you know, history would be very different. In the case of necks, we use locator holes on the neck blank so fingerboards can locate and align properly on the neck blank. And then all the various operations for machining and processing the neck has a reference or a witness point on that component. So a neck will have its locator holes, a fingerboard has its matching locator holes, and then right before they're joined, we install dowel pins, and that locates that fingerboard onto the neck to ensure that scale is accurate and that the fingerboard is positioned appropriately on that neck. Other tasks that are done at the neckline in the rough mill include gang drilling of the headstock hole. So instead of drilling each tuner hole one at a time, we'll have gang drills, so that it'll drill 6 tuner holes all at one time. We also machine the headstock closer to its final profile and pitch, and prepare it for later finishing here at this plant. It's still very exciting for me. You know, I walk in the Gibson building and I see the Gibson logo, you know, at the entrance. This is my 40th year of doing this in the guitar business. My very, very first guitar was a Gibson. It's surreal that I'm here. I would have never dreamed of being here when I received my first guitar.
I've been here 37 years. That's over half my life I've spent at this facility. I've always kind of taken it personal. I look at Gibson like it belongs to me.
The thought of having both the opportunity and the obligation to be the leader of Gibson, it's really a noble cause. How do you take the 125 years of earned iconic status? How do you make sure, first of all, you preserve that for the future, but of equal importance, how do you make progress with an iconic brand? It shouldn't just be about what you inherited, it's what you bring to it and how you play it forward maybe for the next 125 years. So it's both an opportunity and an obligation to take an iconic brand like Gibson forward.
The ES models that we make are semi-hollow body guitars. ES stands for Electric Spanish, and the thin line ES models were initially introduced in 1958. We even use some of the presses, top press and rim press here, that we've been using ever since we introduced those models. They're very different than making just regular solid bodies because the construction is just so radically different. Typically, the backs and rims will be 3 plies, maple, poplar, and maple that are glued together. So we have to press the tops, heat press and form them and glue them together, trim the rims, join them to the core, add the braces to the top. There's a lot of stages that they have to go through that you wouldn't do on a regular solid body. The plies on the ESs are comprised of a maple inner and outer ply with a poplar inner core. And the poplar core is rotated 90 degrees in terms of the grain orientation, so it adds structural rigidity to that lamination. We apply glue and then it's inserted into the press, either the top press or the rim press, and high pressure and high heat. So typically about 250 degrees Fahrenheit and a couple thousand pounds of pressure form the rim assemblies and the top assemblies.
We'll put heating elements in these holes right here to heat this thing up, and when it's ready to go, it'll open up and the operator, he'll put his laminates in there with the glue on it, lay it up in there, hit the palm buttons, and it'll come down and bend this shape, and it'll stay in there for a couple of minutes, and when it comes out, you have a shape of half of a guitar.
Then they're removed from the presses and put on drying racks. And the drying racks, in the case of the rims, are kind of configured to that shape, and they're clamped in to allow the rims to cool and retain their shape. When we glue the rims up, we glue them about 12 inches wide, and then we put them on a large bandsaw and then just slice them like bread to the appropriate thickness for the rim assembly. After we cut the top and the back come out of the same press, and then we have a CNC machine operation that will drill locator holes into that top or back, and then cut the perimeter, and then in the case of the top, the F-holes or control holes. Now we have a 2-piece rim assembly. We put that into a fixture with the center core, we apply glue, and then clamp that all together. So then we have that rim assembly ready to have kerfing, which is also known as a liner strip. And kerfing is slotting that lining strip to allow it to bend and become more pliable. So that's glued on the inside of the rim on the top and back to provide more glue surface for when that top and back are joined to the rim assembly. The ES models are very unique because it's really a hybrid of the electric and the acoustic, more centered on an electric thing, but because of its construction, offers a more resonant and airy tone to it compared to a standard solid body.
When I first came here, I knew it was just a guitar company, and Gibson grew on me real quick, so I found out it's one of the best. And we try to keep it that way, you know, through the years and through the owners and plant managers and stuff.
Anytime you have a changeover in ownership, you kind of got to feel them out. You know, it's kind of like, oh no, there's somebody new in the house. And are they going to mess up my company? You know what I mean?
The first time I walked in, I think there was probably a little bit of trepidation. Who's the new guy? As people were looking at me with a bit of trepidation, I also had the same trepidation. Do I know enough? What can I contribute? What do I speak about? And we collectively aligned on this whole vision about becoming the most relevant, the most played, the most loved brand again. We take all the learning from 125 years of shaping and creating and crafting sound, and let's set the conditions to do that again. Our number one quest was quality, and I can see it happening live in front of us.
Well, when I hear the Gibson name, it gives me many different emotions. And it goes from heritage and legacy and a history that is so incredibly rich, but also innovation and a drive for the future. Orville Gibson is the father of Gibson. He was a luthier. He lived in Kalamazoo, Michigan, where he had his workshop and where the company was incorporated. And that is where we came from. To my right, we have the first mandolin that Orville ever made in 1894, and the last one that he ever made in 1906. Look at the progress of where he started and where he ended with his mandolin. The craftsmanship that goes into it, the beautification of the instrument, the inlay work, all this was done by hand, by him, in his workshop. That's why we have instruments that have binding, that have inlays, that have beautification on the peg heads, that have a carved top. That's how we make guitars today.
Binding is used on guitars, on acoustics or semi-hollow, like in the case of the ES's. Its initial reason is to dress off the rim and top or back to add a feature to hide that seam. And you could say it kind of adds as like a bumper, but on a solid body, it's mostly aesthetic, you know? So in the case of a Les Paul, you don't really have to have it on there, but for the iconic Les Paul standard, you expect binding on it. Gibson's always used the rope method ever since we were binding guitars. It's where we use a canvas rope, and after we apply the glue to the binding, we wrap it around the guitar, hold it down at the waist, and then start that wrapping process.
With the wrapping for the binding, there is a pattern, and you have to get that down, and everybody does the same pattern. It's the same sequence of wraps, and we don't really veer off that too much. We go counterclockwise, making sure there are no gaps, and applying different pressure to different areas of the body.
It has to be in a specific sequence around the perimeter of the body, inside the waist, inside the cutaway, on the tip of the horn. Those are all critical areas that you have to have the proper tension to ensure that you have no gap or maybe a fail down the line. So it's very, very critical. The binders spend at least 2 months learning that trade before they can, go solo and start binding. At first, it's overwhelming and it looks like a messy spiderweb array of rope wrapped around the perimeter of the guitar. But if you compare, they're always going to be in the same sequence. And that was just handed down from binder to binder.
Most of my time I spent binding guitars in a body line. I don't think there's been a lot of change as far as the process. I mean, we pretty much, still do a lot of stuff the way we do them, just like I said, binding. I mean, everybody thinks they're going to try to come in there and change that, and it's been that way for years. And I don't think they'll ever change it, but I think that's just one of the things that makes it guitar different from everybody else.
The glue that we use for the binding is basically the binding itself ground up into a powder, and then we mix it with acetone and solvents like that melt that plastic and turn it into the adhesive holding the binding to the guitar itself. The solvents will then eat into the binding, so when we put all that pressure from the rope, that binding will then melt into that edge surface of the body that it's being glued to. That's where we can get a nice clean seam. After the binders finish binding the guitar, they'll indicate when they finish it, then they know how long to let it dry.
We have a system, a single piece flow, where it goes up on a rack, and once we fill up those 20 spaces, we start over again. And by the time we start over, it's dry. It's ready to unwrap, and we can send it down. The
average binder will typically average 50 guitars per day. which is just incredible. After the guitars are bound and unwrapped, they then have to be rim sanded. And that's basically a belt sander with a table that the guitar sits on, and it's rotated around that belt sander to sand that binding flush with the rim of the body. In the case of guitars that don't have binding, we'll still generally rim sand them just to remove any cutter marks from the machining process. After the rim sanding, guitars then go to the slack belt sander. In the case of a Les Paul, where you have a contoured maple top and a flat back, the guitar will sit in a fixture on a table that slides under a big belt sander. And it's so large that, it's kind of slack in the center. The operator will move that body under that sanding belt, and if he's doing the back, he has a wood form with felt and a handle that he'll slide over that back, pressing that belt on it to sand the back flat. And when he sands the top, he'll wad up a rag into a ball, and then he'll press the bottom side of that rag into the sanding belt, which conforms into the contour of the maple top.
I am in the factories every other day, and I watch all of our craftsmen, our artisans, our people here being so proud of what they're doing. And we celebrate craftsmanship. We are a modern day USA-made and US-centric manufacturing business, and that is the legacy that Orville left us.
When you think about Gibson, you clearly think about the guitar and you think about the artist. Those are the two things that often come together. But when you wind it back a little bit, those guitars are actually made by people. And I think it's a human dynamic to say, if you're part of a family, you want to be part of a winning family, a family that's making progress, not afraid to challenge things. And I think we're creating a culture that's not just a Gibson team or Gibson employees. I think we're truly creating a Gibson family.
Since I've been here, I've noticed that there's a little bit more pride in the work that people do. And it seems like no one wants to send anything out that's not perfect.
It feels good to know that you're making a product that people like to play and buy and say, hey, I own one.
I think people are taking a little bit more pride in it, mainly because they're being trained better now. Gibson has started new training procedures, so you're not just all over the place. And it also helps when you get to see the finished product. Once you see the finished product, then you can say, hey, I had a part in that.
Gibson typically uses rosewood and ebony for the bulk of our guitar models that we offer. Now the fingerboard is the playing surface that holds the fret wire and has your position markers and side dots. The fretboard has to be slotted accurately because the position of the fret wire is what determines the notes that are played on the guitar. Rosewood and ebony, aside from looking different, rosewood has a bit more open pore in the feel of the wood. So it has a little more granular or grainy feel to it. Ebony will tend to be smoother because of the closed pores, and in terms of sound, ebony, because it's such a hard wood, will typically be a little bit brighter sounding, offer a little bit more brightness and sustain compared to rosewood, which typically has a little bit softer or warmer feel by comparison. When we process the fingerboard, we'll radius the fingerboard, and depending on the model, most of our guitars will have a 12-inch radius fingerboard. And then we do make some models like the Les Paul Modern and SG Modern that have a compound radius. And by compound, that starts out, instead of 12-inch all the way along the surface of the fingerboard, a compound will have a radius that graduates from a 10-inch radius at the nut to a 16-inch radius at the end of the fingerboard. So the theory being that it's kind of a conical shape, and that facilitates a lower string action and still facilitates chordal playing at the open positions and then flattens out as you play higher up on the neck for solos. Prior to radiusing the fingerboard, we put initial locator holes in the fingerboard. You need the locator holes on the bottom of the fingerboard to locate on the machine that will radius the fingerboard, and then locate on the machine that will machine the inlays or drill the top dots or slot the fingerboard. And then finally, when the fingerboard is joined to the neck, those dowels will locate that fingerboard onto the neck. When we machine for the inlays, the fingerboard is already radiused, so we use those locator pins to locate that fingerboard on fixtures on a CNC machine. We then machine the various inlay patterns. It could be a single dot, or it could be a trapezoid or block inlay. We then install and glue in the inlays with epoxy, and then we do a final surfacing operation to true up that inlay surface with the top surface of the fingerboard. We install the inlays first. That way, if you have any glue squeeze out, it's not going to puddle up inside a fret slot. So then we clean off that fretboard surface and true up that inlay. Then we slot it, so when we go to fret it, it's a good clear slot that will accept the fret wire. For people who don't know what a fret wire looks like, the side view is kind of a T shape. So it's round, but under that half round, you have a tang, and it sits in that slot. And then that tang also has barbs in it, so when you tap that fret wire in with a hammer and then a press, that barb will bite into the sidewalls of that fret slot and hold it into place. It's kind of like a big wide nail to where you're tapping it in a slot instead of a hole. After the frets are installed, then the guitar fingerboards go through a final tapering process, and that will trim the sides of the frets, even with the edge of the fretboard, into that final taper, which is narrower at the nut and wider at the butt end of the fingerboard. On guitar fingerboards with binding, after the final taper, we glue on the binding, and then they go on to another drilling fixture to install the side dots.
Right now, I am the side dot operator. I actually run a computerized side dot drill that puts side dots in the side of the fingerboard.
We use an RFID chip under our fingerboards, so we can use it for internal inventory and tracking within the company and within the process. Before the fingerboard is glued onto the neck, we install that RFID chip, and then we scan it, and then as that neck and fingerboard move throughout the manufacturing process, we can digitally track where that is. The fretboards are slotted on a machine that we developed that holds 18 fingerboards on a round turret. We use the locator pins to locate them, as well as vacuum to hold them down onto that turret, and it rotates. So as those 18 fingerboards rotate, they're rotating over an arbor that has a saw blade for each fret slot location. So all the fret slots are slotted in at one time. That way, there's no possible variation in the fret slot, which could affect the scale and the tuning. We use a lot of different fingerboard inlays or dots on different models. If you're thinking of a Les Paul Standard, you just expect to have that trapezoid inlay. It's just part of the vibe of the Les Paul Standard. Les Paul Custom will have the rectangular or square block inlays, and that's the vibe of that model. We have parallelograms, some of our ES models that we'll use, and then dots on other guitars. You know, if you see a Les Paul Special or Junior, you expect dots on that. They all serve the same purpose. They're just different aesthetic variations of that.
No joke, I'm telling y'all right now, when I first got here, I thought that it was just a big block of wood. I never knew that it takes time. You have to put the inlay in, you have to put the binding on, you have to put the mud on. To know that the guitar is not just slapped together one big piece, that makes me say, I'm glad about it.
And everybody can tell you, a day never goes by. I'll always say there's never a dull moment at Gibson, never. Something new, something exciting is either gonna happen, or a new guitar is gonna come in that you've never seen before. The color scheme is just like, wow, look at that, or just the make it model of it. From the employees, from the product we put out, and I love coming here just to see what's gonna happen today, you know? So, I'll still be here.
Les Paul was another visionary, not just a musician. He was constantly pushing the envelope of innovation, of sound. At the time, he was one of the most well-known and successful musicians, and we get him to start working with us into what ultimately becomes his endorsed solid body electric guitar in 1952, the first Les Paul gold top electric guitar, solid body electric guitar.
When we receive guitars from the rough mill, the first stop is the neckline. We'll first install the headstock overlay or veneer that has the Gibson logo on many models. Sometimes they're blank if we're going to do a silkscreen logo like on more affordable guitars. And then they go to the first CNC machining operation here. The CNC machine has two tables that move independently of one another, so they each hold 10 necks. We install 10 of the same model necks on each table, key in the appropriate program, and then it machines that final neck shape a lot closer to the final shape that we all feel. After that, we then glue the fingerboard to the neck blank. It's basically a table type affair that holds 10 necks in each station. We hit a valve and we use fire hose, which inflates and conforms to the back of the neck. So it's very quick and very uniform pressure to hold that fingerboard to the neck, so there's no hot spots or potential for that fingerboard to have uneven pressure. So it's a great smooth surface. So after the final CNC neck machining operation and the fingerboard is glued on, they have to get the final hand roll. The final neck shape is done by hand. We can't do that close on a CNC machine. So you have to have skilled people do that final hand roll. The hand rollers, again, are very, very skilled craftsmen that take months to learn that craft. They have to not only make that neck feel good, but it has to be dimensional. We have a lot of different models that have different neck thicknesses and neck shapes. So they have their calipers that they'll have to verify the necks are dimensionally sound. They have different shapes, whether it's the C or a D, 50s round or a 60s slim taper. So they have to make sure that not only does it feel good, but dimensionally everything is to blueprint spec. So we like to say CNC machines make great guitar parts, but people make great guitars. After the necks are hand rolled and inspected, we then scan the neck at that station and we print out the tag that will then also accompany the guitar, which has the SKU for that model as well as the serial number. So our serial number system, this year we went back to the Julian date instead of sequential. The first and fifth digit of that serial number indicate the year that the guitar was made. The second through fourth digits are the day of the year in which that guitar was made. So now you can actually date the guitar off of that serial number. And then the final three digits will correspond with the sequence of how many guitars were made that day. And then we also use a separate arbor press and press Made in USA.
So what we have here is the 1952 ledger. The ledger is the book where we recorded every single guitar that shipped out of the factory. Normally what you see in the ledger is the date, what is it that was shipped out of the factory, and then whether it had a serial number or a part number. We don't start serializing guitars until later in 1953. So in the 1952 ledger, what we have is the guitar, who it went to, and the part number of the case normally. And this is a very important year and therefore a very important ledger because this one carries on May 20th of 1952 the entry for the first Les Paul that ever ships out of the factory. And it's two of them, so it says two Les Paul, and the part number of the case. That means two Les Pauls shipped to Les Paul, and then it has the part number of the case.
On the top of our headstock, we have our signature Gibson open book pattern. It's sometimes called the open book. Sometimes people will call it the mustache because it kind of has that mustache shape. The guitar neck prior to that is just kind of paddle shape. The headstock veneer is glued on and we install it in a fixture and we have a shaper cutter and the blades are shaped to that open book or mustache shape. So in one pass, that will machine that shape into the top end of that headstock.
Les was an innovator, and he was not happy with just being a consumer of music and of sounds. He wanted to innovate and create sounds. He wanted to create ways of recording sound. And I find that that resonates with a lot of our younger audiences that not only want to consume content, they actually want to create it. And I think that the legacy and the spirit of whether it's Orville or Ted McCarty or Les Paul himself, I think that still lives in this building. It lives in what we're doing, in all of our processes. And I really hope that when they look down on what we're doing and they look at us, that they're really proud.
I guess my favorite guitar that Gibson makes would probably be an SG.
It's got to be the standard, the LPS6. I just love the feel of it. The neck is got a 60s neck on it, and just the playability is incredible.
I'm starting to get a little bit more fond of the ESs. Growing up, you know, Saturday mornings or family reunions, we gotta play some B.B. King. So I like an ES. They're nice. They got some style to them.
I wanted to be the kid going across the carpet, you know, playing the broom. My grandmother was like, "Don't be touching my brooms." So my grandfather ended up buying me a Gibson, it was a Sonic Deluxe 180. And, you know, I just couldn't put it down, so it was really cool.
After we stamp in the serial number and Made in USA, the necks then get matched up with the appropriate bodies and go to the neck fitters. The neck fitters then have to hand fit that neck into the body. Even though we have climate control in the facility and we have kilns to cure our wood and equilibrate it, the wood can still expand and contract, enough to interfere with the proper neck fit. So the CNC machines are highly accurate, but because of that potential movement, we intentionally make the tenon of the neck larger than the mortise of the body. So then the skilled neck fitters have to come with their chisels and fine fit that neck into that body. They also have pitch gauges and alignment gauges to ensure that neck is fit properly. The alignment gauges make sure that the alignment of the neck is within center line of that body, and the pitch gauges make sure that they fall within the proper pitch off the top surface of the body, so we have the proper action adjustment capability with the bridge.
When you're here for 20 years, you get to have any guitar you want made that we make. I had a Supreme made. I went with a flame maple top and back, quilted mahogany neck, and a flamed mahogany body. No F-holes, that would ruin it. You don't put F-holes on a Supreme. But yeah, the neck in particular, I ran across 12 years ago. And I seen that neck and I wanted that for my 20 years. So, you know, at 10 years, I knew I was still gonna be here for 10 years later. So I had to continuously move that neck from one spot to another so it wouldn't get lost for 10 years. So yeah, I'm very, very happy with that guitar. Turned out beautifully too, man. I love it.
Gibson is very proud of their set neck heritage. We've dabbled in bolt-on necks in the past, but most of our guitars are set necks, so that neck has to be fit into that body. It takes time and takes a lot of skill, but once it's fit to that body, it's always there. It's not gonna move. So that's great in terms of the longevity of the guitar. You don't have to do any adjustments. You don't have any necks working loose. And then it also, and more importantly, affects the sound. Now you have a lot more sustain and resonance because that's all one, and that's part of our signature tone. The proper neck angle or the neck pitch ensures that you have optimum playability. If it's too shallow, you might not get enough adjustment out of your bridge. It may, you know, hit that body and be too low. If it's too high, you may have to raise that bridge up too much or raise your pickups up too much to where you're not going to get the proper action either. It has to fall within the appropriate pitch window that we define for each model. The neck fitters use various chisels to ensure that they properly fit that neck into the body. They have various size chisels and they have to sharpen them routinely as they're working on them. And there's an appropriate gap that has to happen. And that's why it has to be done by skilled craftsmen. The neck fitters have to be conscious of the allowance of that tolerance for that tenon to fit into the mortise of the body for that basic fit. That's just the fit of the neck itself into that mortise of the body. But they also have to be conscious that they have proper alignment. They could take more off of one side or the other on that tenon, but now their alignment is off. So they have to make sure when they're fitting, they're taking it off evenly, so they're ensuring the proper center on that from the neck to the body. And in addition to that, they have to have the proper pitch off of the body. For necks, we use an aliphatic wood glue. Again, it's tight bond style glue, industrial version. On all our wood gluing operation, the clamp time is 30 minutes. The guitars don't undergo full strength until they're all the way through the production process, and at that point everything's cured. So that allows us to make a guitar very quickly and still have proper clamp time and all those processes involved.
I got a Les Paul Supreme, and it's pretty sweet. You know, it's actually got it for my 40-year guitar. It's changed a little bit. The first year they done it, in the big meeting, they gave everybody who's been here 20 years a very nice Les Paul Custom Plus, I think it was. At the 40 year, they let you pick it out, what you wanted, you know. And so that's what I picked out. The wood buyer brought in a bunch of wood, and I got to pick out my own wood, my necks, my fingerboard, and, you know, and I ran it off the NCs in the mill room. I got to route the pickups in it, you know, and just do a lot of the work to it myself. It still means a lot to me, you know, it's the Cadillac, Rolls Royce of guitars.
We do the final machining of the bridge, tailpiece, and pickups after the neck is glued into the body. The reason why we do it after the neck is joined is to ensure we have accuracy along that neck. We have locator fixtures that self-center and clamp the neck into the CNC at each station. We also have a gate that locates off of the nut. So now we ensure that our scale is accurate and that the neck is held under that CNC machine perfectly on center. We machine the bridge, tailpiece, and pickups at that stage, so now that's all accurate and truly on center. My very first guitar was a Gibson SG. I was very fortunate to start out with a great guitar. For me, it's just surreal to be here today. I look back and I would have never dreamed I would have done this for a living or be here, you know, the company that made my very first guitar. So that's very cool, and I'm very proud of that.
Incorporating new technologies will not happen because I think something is cool or JC thinks that something is cool. We launched what we call the Gibson Lab. The Gibson Lab is all about testing innovation. It's also about manufacturing practices.
Gibson started using the Plek machines in the early 2000s. We first started out with 1 or 2 machines, and then we added more. Initially, only certain models above a certain price point had the Plek process. And then we added more machines to where now every single guitar that Gibson makes, whether it's at USA or Custom Shop or Montana, everything goes through the Plek process. So that just ensures we have the most accurate fretboard surface possible. After the final machining of the bodies, the guitars then enter the Plek room. The Plek room is the fret leveling and profiling operation. So guitars each have their own Plek program. It's a CNC machine that will level the frets and then give it the final profile, which is the round profile of the fret after it's been leveled. So each model has its own specific program on the Plek and its own specific fixtures. Guitars are loaded in those fixtures, then they go into pre-tensioning jigs that tension the neck to simulate string tension. They're then located in the Plek machine, and then the program is keyed in, then they run the machine, and it starts a scanning process. That scanning process scans the fret surface under each string path, and then it's a plunger affair, and every time it hits a fret, that plunger moves up and down, and it records digitally what that movement is. So after it completes that scan, it has a digital topographic map of that entire fretboard surface. Then it comes back one by one and machines each fret to its proper height and profile, which is incredible if you think about all that digital information stored. It might take 1/1000th off at the beginning of the fret, maybe 3/1000ths in the middle, maybe skip the last part, and every fret could be different. It takes it to the final height, the final profile, and lastly, it'll slot the fingerboard nut. So now that's guaranteed accurate and on center.
I am a Plek operator. I started out as a fret filer, where we used to level the frets by hand, and now we changed and went to the Plek machine, which I am highly grateful for that. Well, when we used to fret file, trying to do that by hand and doing so many guitars, your eyes may get tired, and your shoulders would definitely hurt from having to rake across the frets. But a Plek machine is more accurate because you're taking something, measuring this, And when your eyes get tired, the machine doesn't get tired like my eyes may get tired. So I definitely appreciate that. It helps in the quality. Plus the playability is probably far more better when you're talking about measuring something at the thousandths of an inch compared to me looking at it with my eyes. So.
If it says Gibson on the headstock, you know it's made entirely in the United States, it goes through the Plek process, and it's a true nitrocellulose finish.
Well, I think it feels good whenever you can be a part of something that is sustained so long, and knowing that I'm a part of and I'm building guitars. I'll give you a good example. When I went to Guitar Center, I was telling my son one time, hey, I made that guitar. So I think it feels good when you can say you are a part of something, and it's a good something. So Gibson having the name that it has, and I can go somewhere, hey, I'm the Plek operator, I Plek that guitar. I think it's always a great thing.
The first thing I want people to think about when they think about this new era of Gibson is the highest quality guitars that Gibson has ever made in the history of the company. And that is where everything starts. I want a look back to say they were onto something. They really borrowed from the history and took it forward to take the company into another dimension with what they're making, the quality of instruments they're making. And I think that if we get our fans and our artists to say that, that means success.
Been here for 14 years, and even in my own department, it's changed completely. We've learned a lot of new techniques, and we use a lot of newer equipment now than we had when I started. So it's a lot less hand blocking and hand tools and more small orbitals and better equipment that we're allowed to use now, which makes the process easier. And the final product is way better than anything we could have done even 10 years ago. So we've definitely stepped it up as far as the quality that we can put out of this facility.
After Plek, guitars then enter color prep. Color prep is where guitars receive their final sanding and wood filling prior to finishing. It's a single piece flow, so every operator has a specific area of the guitar that they're sanding. That allows them to really focus and key in on, say, the contoured top of a Les Paul, or a neck shape, or a neck heel. That way, they're all specialists in that area of the guitar, so it's very efficient and guaranteed to be a lot more accurate and in tune with what should be the final result. Lastly, guitars then get wood filled. The wood filler is a paste wood filler that is a consistency of pudding. The purpose of the wood filler, in addition to highlighting the grain, more importantly, is to fill the open pored grain of woods like mahogany or swamp ash. Open pored woods need that grain to be filled, so when they get lacquered, that lacquer just doesn't sink into the holes. So now we have a smoother finish after the whole finish process. The final sanding is very important because through the manufacturing process, at every step you're taking wood chips off, you're carving into the guitar, or you're sanding with heavier sanding belts or spindle sanders. So the very final sanding is to remove any fine scratches left from any of the previous sanding or machining operations. In the case of an opaque finish, you'll still see little sanding scratches as that lacquer settles if you don't get them out removed. In the case of a transparent finish, if you have any fine scratches left into that wood, when you stain or shade a guitar, it's going to be highlighted and exaggerated. So the final sanding is hugely important into the final aesthetic of the guitar. So the grain filler, also known as wood filler, are tinted. So on transparent colors or shaded colors, we'll use a complementary colored wood filler, such as a cherry or walnut brown or red mahogany or a white wood color to accentuate the wood grain. So it adds kind of a staining operation at the same time. On opaque finishes, it doesn't matter what color wood filler we use, but you still have to use a wood filler to fill and pack the pores of the open grain woods. On woods like maple, that's a closed grain wood, so you don't put wood filler on that. There's no need for that. We apply the wood filler with a brush with the grain direction, and that packs it into the pores. We let it haze for 3 or 4 minutes, and that kind of cures to a certain extent, and then we wipe it off cross grain. So that packs that wood filler into the pores instead of pulling it back up out of the pores.
So we will get direction from the engineering department on the models coming through, whether it be a new color or new model altogether, and what they're looking for as far as the color, like if there's a theme to it. So color prep will work with the finishing department to figure out if we are going to use specific filler, water-based or an alcohol-based stain, and then what colors we need to use to get the right effect in the finishing department.
Then it goes to the final inspector, they approve the guitar, and it goes up into the carousel, which ramps up into the ceiling up above color prep and cycles for 8 hours before then we can pull it down and take it into finishing. Heat rises, so that accelerates that drying process, and they have to dry a minimum of 8 hours to allow the solvents to evaporate before they can go into finishing.
From the first day I've started working here, it has been a sense of pride and real exciting to walk into the place. It's a brand everybody knows, so just to have the chance to get a shot at it and then feel like I'm succeeding at it. So yeah, over the years it doesn't really wear off. It makes you want to come back and do more and do better and get to work on anything you could possibly work on. So the chance to work on new models, new colors, and then just working with the people that you grow up with, in a sense, as you're learning the job. You watch your seniors work and just make these beautiful pieces of art, really, just out of blocks of wood. And these are the things that people all over the world want. You watch them take pride in it, you want to do it, you mimic that, and it moves from you to the next person that you train, and then that they'll train. So that'll just go on through each generation of employee that comes through the place.
So I come in at 5 o'clock in the morning and I start counting all the guitars that we have to work in for our production goals for the day. Then throughout the day, I'm doing a lot of quality checks and training, some creating, which is a lot of fun. I also do artist guitars if there's an artist that has a special request. My favorite music artists would be Nancy Wilson of Heart, Lizzie Hale of Hailstorm, and of course Joan Jett. I have actually met all 3 of them. I've painted guitars for each of them, and it's always fun to create guitars for your favorite players.
In finishing, we have different spray lines depending on what we're spraying. For instance, we have a metallic booth that does only gold, silver, and other metal flake colors like that. So on that line, we keep those colors isolated because metal flake can become airborne and contaminate other finishes. So that's a completely isolated spray line. We also have another spray line that does only light colors, a white or yellow or maybe a powder blue, certain light colors like that, that again can be affected by contamination, are isolated. And then we have the majority of our other spray booths are in our main spray room that does all the shading of natural wood tones, sunbursting, and colors like that. Gibson is very, very proud of the sunburst finish. For one, Gibson invented the sunburst finish. It's a shading around the perimeter of the guitar body. It just is a type of finish that pretty much any company who makes guitars has adopted. It's a very attractive finish that comes in a wide variety of shades or colors. On the Les Paul Standard, it's very closely associated with that. However, we're using it for decades before the Les Paul Standard. It's so iconic and tied in with that Les Paul that a lot of people just referred to the Les Paul Standard as the sunburst. A sunburst finish starts out by receiving a shade in the center of the guitar body. In the case of a Les Paul Cherry Sunburst, it would start out by having a transparent yellow shader over the face of the guitar, and then it gets a cherry red shader around the perimeter of the body. And it's typically laid out into a teardrop pattern. So it follows the butt end of the guitar around the perimeter and around the cutaway and where the toggle switch is, then it will fade into a teardrop pattern. So it's that teardrop pattern that's very, very iconic in that cherry sunburst. After the very skilled painters apply all the colors, all the shades, the sunbursting by hand, then the guitars are loaded in the electrostat line. The electrostat line is where all the clear top coats are applied. So the guitars hang by the headstock on a hanger, and then we have a wire that's connected to that hanger that connects to the truss rod. That truss rod spans that length of the neck, so the finish has a low voltage electrical charge applied to it. The guitar has the opposite charge, so as the guitar goes through that spray booth, the finish and the guitar, since opposites attract, that finish is applied electrostatically, which is normally only used in metalworking, such as automotive. But in the case of us, having a neck that has a truss rod that's steel and a neck that's glued into the body, it's conductive enough to where we can use an electrostatic process. Now, the benefit of that is you have skilled people applying the color that you can't automate. It has to be done by hand because wood tones can change. So if you're doing, for instance, a cherry sunburst, they have to know, hey, if this top is unusually dark, I may need to pull back and speed it up, to maintain that same color tone. They may have another maple top that's unusually light. So they may have to lean in and slow down a little bit to maintain that same color tone for that. So skilled people have to do that by hand. Clear top coat, the benefit of the electrostat line is that since it's electrostatic, now you have less overspray, less waste, better for the environment, better for material coverage, more uniform coverage, and then uniform thickness.
It's really awesome to know that when you see those guitars on stage that you painted that one for sure. If you're doing production and you see guitars, you see artists playing guitars, you're not really sure, like maybe I did, maybe I didn't, but when you know you actually created a guitar for a specific artist, especially your favorite, it's really awesome to see them playing it.
High gloss Gibson guitars will typically get 4 coats of lacquer during one pass in the evening in the electrostat line. Then they're scuffed down to level down some of that orange peel to smooth that finish down. And then they're given 4 more coats again. The bottom line is we want to have enough finish on there to have that high gloss and luster and that depth, but we don't want too much. There's that fine line. You want to have enough depth and clarity into that finish, but you don't want it so thick that the guitar will look cloudy or inhibit the resonance, which is another benefit of having nitrocellulose lacquer as a finish. It's a thin coat compared to modern day polyurethanes and polyesters that some of our competitors use. They are many, many times thicker than a nitrocellulose lacquer, and even on a solid body, that will affect the resonance of the guitar. On a high gloss Gibson guitar like a Les Paul Standard, it will typically take 2 processing days to apply that finish and then between 4 and 6 days for cure time. After the color is applied to the guitars, Gibson applies the logo of the model and then sometimes the Gibson logo with the silkscreen process. In the case of a Les Paul Standard, the gold Les Paul model is applied with the silkscreen. The Gibson logo is already inlaid in mother of pearl in the headstock. The silkscreen process is a historic silkscreen process that we've used for decades and decades. There was a period of time in the 70s where we went to a water slide decal. And with the decal, as the finish settles, you can see that halo around that water slide decal. And it just wasn't a historic feature. The silkscreen, you only see the silkscreen of what you're screening on. So on any parameter, whether it's the application or the look, the historical accuracy, it's just win-win-win all the way across the board.
I really, really love the creating of the guitars each day and take a lot of pride in trying to make sure that each one is as good as I can make it, whatever part that I'm doing to the guitar. I do take a lot of pride in making sure that it's as good as it can be.
Have I ever tried to build a guitar? The answer is absolutely yes. Back in shop class when I was in grade 11, so junior in shop class, we had this project where we were given a very nice piece of mahogany wood and we were supposed to make a cutting board. And I noticed there was a much bigger piece of mahogany and I asked the shop teacher, I said, hey, what's going on with that wood? He goes, that's a special piece for someone who has a special idea. I said, I have one. I want to make a guitar. And he looked at me and said, then that's for you. So I proceeded to take this beautiful piece of mahogany, drafted it out, put it together. I had an old guitar that I deconstructed and then built my own Flying V. And I learned more about the dynamics of craftsmanship, right or wrong, on my build. But knowing what I know now here at Gibson, if I could go back in time, that Flying V would still be in my collection.
After the color coats are applied to our bound guitars, they then go into scraping. On our guitars that we finish that have binding, we don't mask the binding, we just go ahead and spray over it. You can use fine line tape and tape like they use in automotive, but it's not quite as clean as that is required for our guitars. Say on the Les Paul, the cream binding with the cherry red back, that line where that cherry meets the cream binding has to be sharp, and tape just won't allow us to do that. So we go ahead and spray over the binding on the side and the top surface. Our scrapers hold the scraper blades between their thumb and index finger, and they have to painstakingly scrape that color off, that binding, without getting into the body. So it requires a great deal of skill. Typically takes 6 to 8 months of training before they can be let loose and practice on guitars in production. The blades are made by them. They trim and shape all the blades. Each individual scraper shapes them themselves, sharpens them themselves on grinders, and then on files as they're doing it. And they have a dozen or more different sizes and shapes of scraper blades, depending on if they're doing the outside of a Les Paul body or the inside of a cutaway or around the tip of a horn or along the length of a fingerboard. It's very skilled and very detail-oriented.
Gibson's always been synonymous with crafting, whether the way back in the days of Kalamazoo or here in Nashville. And I think there's a certain element of both pride and craftsmanship that comes with a Gibson guitar. And Made in the USA shouldn't just be a moniker that we put on there because we think we have to. We want to do this. We want to build the craftsmanship and the quality and the pride and, quite frankly, everything that goes with it. And if you think about all the artists who have played Gibsons over time, they're synonymous with the culture of what America brings. And I think for us, even if you stripped away the Gibson name for a second, or the music industry, or the guitar category, making something in the USA can matter. And we want to do that in a balanced way with our craftsmanship and how do we modernize, but then layer on the guitar, layer on Nashville, layer on Gibson, and you've got really amazing ingredients to create something special. So I think it's up to us to make Made in the USA matter.
The scrapers have the variety of scraper blades of all shapes and sizes that they use and shape and sharpen themselves. In addition to that, they'll have what they call guide sticks for the fingerboards. So when they're scraping the fingerboard, they have these guide sticks that locate on the fingerboard nut, and they'll hold that onto the fingerboard, so when they slide along that stick to scrape the fingerboard binding, their thumb isn't bumping up and down on the fret wire or the tape. So it's just, helps them achieve that clean line that's required during that operation. Besides that, they have inside cutaways, they'll have flexible urethane guide rulers, more or less, that they'll install inside the cutaway. So now they can use that as a guide to rub up against and maintain a clean line inside that cutaway. On double bound models, such as the ES 335s and guitars like that, they have binding on the top and back. Now that time is multiplied by 2 on scraping the body, so it takes twice as long. Sometimes a lot of those models are multiply bound, so there are a lot thicker binding on the top, and that takes additional time as well. Chronologically, scraping is inside the finishing process, so it happens after color and before top coat. After the guitars cure in finishing and pass the final inspector, they then go to fret prep. In fret prep, we remove the masking tape off the fretboard surface. The masking tape is used to prevent lacquer from getting on the fretboard surface. We peel the tape and then take razor blades and scrape whatever residual lacquer off of the binding or edge of the fretboard surface. And then we come back with fine grade sandpaper and steel wool to polish up the entire fretboard surface and fret surface. And in the case of bound fingerboards, with our historic binding, we have what are known as the binding nibs. And also in fret prep, they'll come back with files after they scrape with the blades and then shape the binding around each fret to have that binding nib. So that's another very highly skilled task that they have to do as well. After the fret prep process, the guitars then go into buffing.
What fans really expect from a Gibson is that it's going to bring what their vision of their sound is to life for them. They expect high quality, clearly. They expect something that's premium, something that they can help emulate a sound that they've heard and like, but they can also actually customize and personalize the sound based on how they want to play it. So I think there's an expectation of premium quality, which is the starting point. I think there's an expectation of craftsmanship. I think there's a bit of soul in a Gibson guitar where they can say, I'm playing something that my favorite guitarist played as well. And whether that's the replica guitar or whether that's the Gibson brand, I think there's an expectation of the sound, but also the soul that gets created out of a Gibson guitar. And that's a really special combination. And I think that's what makes Gibson so special.
Buffing, a lot of people say it's, a skill. I would almost liken it more to a trade or an art form. It typically takes somewhere from 6 months to a year to really get good at it. It's a complete physical grind all day long. You're basically holding a guitar that's already 8, 10, 12, 14 pounds up against these wheels that are spinning at you at, 1,000 RPMs or so. And that's what you do all day long. Not only do you have to kind of persevere through the physical part, you've got to have the visual acuity to seize these incredibly minor, what most people would say are minor flaws, to make sure that by the time you're done with it, it actually looks like a Gibson.
After fret prep, guitars enter buffing if they're high gloss. High gloss lacquers require buffing to bring that final luster that our fans know and love. After finish, the surface texture still has some shrinkage and maybe grain and orange peel, which has to be sanded out to level out the finish. We take fine grit sandpaper, level out that finish. At that point, it looks like frosted glass. And then we have to use the buffing wheels and then progress through the various grits of buffing compound on the various buffing wheels to bring that high gloss luster back into the finish. The red wheel is the initial buffing wheel that is used to start the buffing process. The red wheel will remove the scratches that were left by the sanding operation prior to that, and it shines it to a certain level that's uniform but still not high enough luster. It then progresses to the yellow wheel. That will remove the scratches that the red wheel left behind, and that will bring it to that next level of luster. And then it progresses to the final white wheel, and that will remove any scratches at that point, and that's that last stage. Throughout those processes, you may have a different variety of width wheels. So you may have a very narrow red wheel or yellow wheel, whatever the case may be. The narrow wheels are used to get inside cutaways or along the side of a fingerboard. And you have a very wide wheel, and that may be used to get the back of a guitar, to ensure that everything is level. If you use a skinny wheel on the back of a guitar, it's going to be very difficult to maintain a smooth surface because it's going to want to rut out because of the width of the wheel. So you have to make sure you use the appropriate wheel for the area of the guitar you're buffing.
I play guitar, bass, kind of most things strings. I guess on a certain level, I think that gives me a greater appreciation for this. And I think even for me as a player, I didn't even realize all the complexity and the detail that went into it. So that's been one of the most fun parts of the last 11 years, is being able to kind of find out those little things that make all the difference in the world in the way a guitar looks or plays, or even sounds with the winding of the pickup, or anything along those lines. There's a lot more to it than most people realize.
In buffing, things can go wrong if you're not highly skilled. And even though it's physical and requires a great deal of brute strength, you still have to have finesse, because you're forcing that guitar into this buffing wheel. And if you're not careful around the edge of a body, or the edge of a fingerboard, or the edge of a headstock, and if you don't have enough finesse to hold it properly, you can burn that finish. And if you burn it, you have to stop and do a touch-up. It has to go back into finishing or finish repair. So things can go wrong real quick if you're not skilled enough in buffing. The buffing compound we use is in a wax matrix. So instead of having liquid compound that you'd use like on your car to polish out scratches, this comes in a wax bar. So the buffing compound is mixed in with that wax. So you rub the wax onto the buffing wheel, and it softens and gets embedded into the wheel. So then you make dust instead of liquid spatter. It's just more suitable for our manufacturing operation.
As far as the buffing process itself, just what I do, we're constantly trying different things. It could be different materials or different compounds or different sandpapers. We really try to dig into the nitty-gritty details, but there's always different processes that are being looked at. There are different things that we're trying to see, all right, can we make what we do even better? Can we make it easier for the next guy to process the guitar and make sure that we get out the quality that we need? I've been here for 11 years, and I've never seen a greater focus or a greater attention to the detail and the quality. And what's been great about it is it's been a progression. It's never been a situation where I feel like we've regressed and stepped back on what we do. That's something that I value personally, is just striving for excellence and just striving for being better the next day than what you are today.
Seth Lover is the inventor of the humbucking pickup. So Seth Lover took the concept that was previously applied to amplifier transformers and amplifier tubes of taking two coils, wiring them out of phase to cancel that 60-cycle hum. So it revolutionized music. It not only got rid of the noise, but it created a new sound. We still make many of the historic Gibson pickups that Gibson has pioneered over the decades and decades. Most notably the P90, which is our big single coil soap bar style pickup, debuted in 1946. And then our humbucker is our most iconic pickup. So when Seth Lover invented the humbucking pickup, initially the first prototype had 2 rows of slugs in the coils. So Ted McCarty requested that, he put 1 row of screws in there to make it adjustable. That way they'd have another feature. So the screws permit individual adjustment for each string to balance that string response. We wind our coils on automated winding machines. Back in the old days, we had automated winding machines which were automated to a certain point, but they didn't have automated stops on them. The consequence of that was back in the 40s and 50s, there's a great deal of variation in our coils. because of that variation, you might have some coils that are wound more than the other in the same pickup. Over time, we discovered that, and we found out that's what happened on many of these pickups. So that's where we have our burst bucker series pickups, where we intentionally mismatch that coil to offset them to have that same character. Nowadays, we have automated stop, and we want to make them truly match, we can do so. If we want to offset them, we do so, and we can do it consistently. Here, Anthony is loading up the machine. In this case, we're using polyurethane insulated magnet wire. So this would be on one of our more modern design humbucking pickups. Now he's adjusting the alignment and tension. The traverse is the movement across the coil, and that's always been automated. With the automatic stop and the synchronous winding of all the coils, they're going to be a lot more consistent and accurate than they ever were. Historically, our humbucking pickups were made with a nickel-silver pickup cover. You know, nickel plated in the 50s and then gold plated as well in the 50s on certain models. In the 60s, we then went to chrome plating on certain models instead of nickel because chrome plating is typically more durable than nickel. Over the course of time and with all the vintage awareness, we went back and then started offering nickel covers and found that nickel and chrome actually do kind of sound a little different. There's a slight magnetic effect with the chrome plating that you don't have with the nickel. So we'll offer the different plating options on all our pickup covers. And then in addition to that, a lot of players in the 60s, when they started using Les Pauls like Clapton and Page and Beck and people like that, they found if they took that metal cover off the pickup, it actually got a little bit more output and a little bit more brightness. So we also offer that. In addition to winding pickups here, the electronics department will also make the hand-wired control assemblies. We call them CPAs, control plate assemblies. They do that in-house on our hand-wired assemblies. Certain models, especially our original series models, will have hand-wired controls since that's what we did back in the old days. So we'll use audio tape or pots, 500K controls on everything. That's what we did in the old days. There was a period of time in the 70s, Gibson were using 300K controls for volumes and then 100K for tone. And people didn't understand the effect that had on the pickups. So by going with 500Ks, pots in all positions, you'll have the maximum output from your pickup and maximum tonality. So you're getting the full sound of that guitar. It's historic and it's just better performing. After the pickups are completed and the control assemblies are completed, then they will go to final assembly where they're installed in the guitars. Working with these people and people at Gibson who are here longer than I have means a lot because I have to live up to what they've already done. There's a lot of history, what Seth Lover did, what Lloyd Loar did. We have decades and decades and decades of history, and that's our reputation. We take great pride in that. I take great pride in it. And all the workers here feel the same way. It's just fantastic.
When I go through each process that goes into building a guitar, I feel that there is not one without the other. Every single part of that process is equally as important in ultimately why somebody is going to fall in love with a Gibson guitar. And so I look at it as every single one of our craftsmen are making their part in giving the gift of music to somebody that's going to pick up that Gibson guitar and fall in love with it and create new sounds. And that I'm very proud of.
After fret prep and/or buffing, the material handlers will then get the guitars and match up the appropriate parts kit with that guitar and put them in racks which they then deliver to final assembly. Each guitar has a parts kit that has all the major components that are specific to that model. So when it makes it to that line, the lead person on the line will then take that hardware kit that's matched up with that model and then start the final assembly process.
So I'm lead in final assembly, going on 15 years. Even after 15 years, it seems that every day is a new adventure. When you combine the different personalities of the people that create the guitar, along with the different personalities of each guitar, really, it makes for a very interesting process and day. Every day is an adventure.
We have 4 final assembly lines that are all single-piece flow. That means the guitar enters at the lead person. He will then do any pre-drilling for the tuner holes, the jack plate, the control covers. He'll then install the strap pins and then send it to the next person on the line. The next person on the line will then install the tuners, and then he may install the control assembly. Then he sends it to the next person, and then he may install the toggle switch and install the pickups, and then he sends it to the next person, and then it makes it through all those successive steps until it makes it to the adjuster. The adjuster then gets the guitar, which is primarily built up except for the tailpiece, bridge, and strings. He will then string the guitar up, tune it, and then start the adjustment process. So once the guitar is tuned up, he'll have to adjust that neck because the tension of the string will affect that, and then file the nut to its appropriate height and shape it, and then he adjusts the pickup height, the bridge height, and the tailpiece height. He'll take a tailpiece that's pre-populated with strings. Not only does it make it faster for him, but more importantly, there's less of a chance of scratching the surface of the guitar by threading the strings in individually. So it's quicker and cleaner for assembly. Once he's done, he then sends it to the cleaner. The cleaner will then give it an inspection, a final polishing, and install truss rod covers and control covers. After the cleaner, then the guitar goes to the final inspector.
Everything that I do in quality control, I inspect the guitars, check them for playability. I look at the cosmetics, I play it all the way up the neck, make sure no buzzes, none of that stuff. So I check the electronics, check the string height, check the at the nut, and I check it at the 12th, make sure everything's good. Yeah, check all the hardware, all the push-pull pots, make sure they play, check the tone pots, check the volume, make sure there's no scratchiness. When I'm done inspecting a Gibson, I'll fill out the tag, check off all the boxes, and then, I sign it and date it. And for me, when I sign that, that's me telling the customer that I've done the best that I absolutely can do to make sure that guitar is perfect, close to perfect as we can get it. And that's real important to me because when somebody opens a case and they pull out their guitar, I want them to go, wow, I want them to have the wow factor.
The final inspector then has to give it its final playability test, and then he takes a photo of that guitar, prints out the photo. That photo is also kept as a digital copy, which we retain, and that digital copy is synced with the serial number of that guitar. He signs off the inspection ticket, fills in the date, the SKU, the serial number, and signs it, and puts that photo with the guitar, and then it goes to the packer. The packer then gets that guitar, matches that guitar up with the appropriate case or gig bag, installs any case candy that would go with that guitar, which in addition to the inspection tag and photo would be the warranty packet, any adjustment tools, and straps that will accompany the guitar in the case or gig bag. That's put inside the carton, and then that's the end of the line. It goes into the warehouse. It may be the end of our story, but it's just the beginning of someone else's story.
When I think about Gibson, I think about this amazing, rich, incredible history for 125 years, shaping sound across generations and genres of music, and at the same time, thinking about the future. I have a huge amount of respect for what they were doing back in the day, and we need to borrow from the learnings that Ted left us, that Orville started, and really lean into the future in a pretty dramatic way, while also preserving our heritage and paying tribute to our past. And so that to me is something that's very important that I keep in mind. I don't take it for granted. And that's what makes it an incredible privilege to be a leader of this brand.
Growing up and listening to the music and daily knowing the impact that Gibson guitar has had on the history of music is really quite humbling. And to be actually working here at Gibson and seeing the guitars that we make every day, I take a lot of pride in that.
I've often talked about, when you talk about the Gibson guitar and the essence of it, it's not just about the guitar itself, it's the journey that it goes on. And we talk about for 125 years, Gibson creating and inspiring and shaping and innovating and contributing to that share of sound. And I think when you look at the cumulative effect of the sound that gets created, the moments that matter to individuals, whether they were the players and the guitarists or the fans they were playing it to, if you put the cumulative effect of Gibson sound, you're in the billions and billions and billions of sound coming out of Gibson into the billions of fans. So I think what makes it special is clearly the build, the craftsmanship, the made in the USA, the wood, the tone, the way we bring it together, and the pride that happens right here in our Gibson factories here in the USA. But then you see what happens to it when it leaves here. It goes somewhere where it gets presented, someone sees it, they've aspired to that all their life, they get it, they start to play it, the sound they create is more personal to them first of all, but then all of a sudden people hear that and the sound resonates out. And it's the complete circle of Gibson, from a piece of wood and some electronics and an amazing environment that gets built and crafted here, right through to the craftsman who actually plays it out there live. I think that's what makes Gibson special.